This is a video of a motion analysis done in SolidWorks. What you're looking at here is a shaft subassembly. The shaft subassembly consists of the shaft itself, these two identical cams, and this 30-tooth gear. There's two shaft supports. They're identical to each other, and they support the shaft. These are the fixed parts, or actually this is the only fixed part. And then we have two followers. They're identical to each other. Each one is mated to the cams. Not mated, actually, I'll come back to that. And then we have a 25-tooth gear. Let me go ahead and start the motion analysis. You might notice that I think it's this follower that actually does a little bit of a jump because it needs to actually get into full contact with the cam when it starts. So there we'll start. Yeah, there was that little bit of a jump there. And as you can see, the followers are moving along. The only driving is happening with this gear. There are solid body contact between these two, between the lower gear and now the whole shaft subassembly. And there's solid body contact between these followers and the cams. All right, I'm going to pause this for a second, just go over the couple items here. So I mentioned that there's a 25 to 30 tooth ratio over here. So if I edit the feature here, you'll see that I'm using a constant speed revolution of 72 revolutions per minute. That gives me, if I run that for a duration of 5 seconds, I get a complete cycle. And the motor is mated to the face of this one gear. All right, so we have solid body contact. If I edit the body contact is between these two gears. And the second solid body contact is between the follower and this cam. And lastly, the solid body contact is between these two parts. Now you might notice, let me go back to the last one there that I just showed. The one thing I haven't worried about is the materials, so I'm just using all the default materials and friction characteristics, which is usually acrylic. At least that's the default for SolidWorks as I have installed it. The followers are maintaining contact with the cams solely through gravity. So I have the gravity vector over here on the right hand side. You can see that it's in the Y direction pointing down, and since we're in the inch/pound/second format, I'm using the standard gravitational constant for surface for sea level in inches per second squared. All right, so let me go ahead and play the video again. So you actually saw the jump there when the cam went back to its initial position. I can look at it using, so you can get a better feel for the motion. Now, as I said, one of the motions, the rise motion, is modified trapezoidal, and the fall motion is constant acceleration. And they are both at different duration levels with regards to angular rotation. The cams themselves are 90 degrees out of phase. I don't know if you can see that here as they come around. Here's the one key and there's the second key, so they are 90 degrees out of phase. Let me just go ahead and pause this one more time. Now I did the settings, the motion study properties. I typically, when you have gears, to get even just a good animation, even though this is a motion study, you want to make sure that you have the frames per second is not anywhere close to a multiple of the gear teeth. Otherwise you'll get either stop action motion, or sometimes the gears will appear like they're running backwards. I've also set the 3D contact resolution to precise contact. I've also pushed the accuracy up. It probably could be pushed up a little bit larger. And what I've done is I've set the cycle time, meaning so the cycle settings is 360 degrees, but in this particular case I've set the cycle time to 5 seconds. That's producing one complete revolution of the entire system. And the last thing that I've modified is under the advanced options, I've maintained the integrator type, but I've pushed up the maximum iterations to 50. I've also increased, or rather decreased, the maximum integrator step size. So this is normally, I think, 0.01. So I've moved it down 2 orders of magnitude. It took a significant amount of time for it to run through the 5-second analysis, but I've gotten decent results, not great results in regards to the kinematics. Let me go down here and show you the results. So let me show each of them individually and the acceleration. So what I'm doing, notice I'm only taking a full cycle here. So I'm going from 0.75 seconds to 1.8 seconds, which is approximately one full cycle. So you can see my rise and my fall. Notice that there's 2 different durations. This one, the fall is considerably longer. Here is the characteristic of a modified trapezoidal. And you can see that I'm getting fairly, well, it's decent down here on the deceleration side of it, but there's this one point that has jerked up pretty high here. So it should be more around, if I take a look at my model, I'm probably expecting my model to be positive 44 inches per second squared. I'm getting fairly decent in terms of the constant acceleration fall. This is what I again would expect for my velocity. For the acceleration, I'm getting the flat curves, but I am still getting some noise over here. So what I would do now is I would start from my linear displacement, right click and export to CSV, and then go ahead and do my numerical derivatives outside of SolidWorks, because SolidWorks doesn't use a very sophisticated methodology for producing these final curves. Note that if I hadn't set up the modifications here on my motion study properties, I would have gotten fairly ugly acceleration plots. So you do need to push up the analysis. So while I have those up, let me actually back the I got to close this down. Let me back the time up just a little bit. So, and then I'll let it play for these few seconds. Actually 1 second. I'm going to move it down to, oh, so I am moving at a fairly slow rate. So if I hit play now, oh, it went from a play from start. Anyway, so about 0.75 seconds, which is right about now. You'll see the traces start. And we're getting a full cycle. I believe it's this one. Yeah, this follower cam is what you're looking at. All right, so that's going to conclude this video, just to give you a full kind of take a look at what you can do with SolidWorks and motion analysis.